Welcome to the School of Life. Life is hard, but you have got to be harder. I'm Mrs. Collins, your life coach. Let's get started with the Unit 2 test review. As you prepare for your Unit 2 test, there are some suggested study materials that you should use as you are studying, as well as that you can use while you're taking your test. Some of those items include your step-by-step guide on writing equations of parallel and perpendicular lines. This graphic that shows you the breakdown of the different types of quadrilaterals you may have given the amount of sides that are equal. Our chart of our different quadrilaterals and the breakdown of which sides are equal, and as well as whether or not we have parallel or perpendicular sides. We have our midpoint formula, the distance formula, the slope formula, perimeter and its definition. You can also write down the formula for finding the perimeter, area and its definition. Again, you can feel free to write down the formulas that we've learned for finding the area of your square and rectangle. We have our flow chart. And lastly, don't forget when we're writing equations of lines, we're writing them in slope-intercept form, which is y equals mx plus b. For this study guide, you'll be given helpful hints to help you to come up with the actual answers for each question. Do note that the answer key is located at the end of the document for this particular study guide. So please use it to check your final answers. But once again, in this video, you will receive some tips on how you can figure out the answer for each problem. All right, so starting with number 1, we have a high school cross-country team is going to Chicago to watch the Chicago Marathon. A coordinate grid is superimposed on a highway map of Illinois. The high school is at the point 2-4, and the start of the line of the marathon is at 6-9. What is the approximate distance between the high school and the marathon? And we're given a key here that says that 1 unit is congruent to 9.5 miles. So for this problem, first off, think about the question that is being posed. So the question is, what is the approximate distance between the high school and the marathon? For this problem, you'll need to use the distance formula. To calculate the distance between the high school, which is located at the points 2-4, and the marathon, which is at 6-9. After using the distance formula, remember that your answer will simply be in units. You'll need to convert your units to miles. And you'll convert your units to miles by multiplying your answer by 9.5 miles. You try it and then check your work. For number 2, we have the map shows a highway rest stop halfway between the two cities. What are the coordinates of the rest stop? So this is a continuation from problem number 1. We have the two coordinates being the high school as well as the start line of the marathon. And once again, it's suggested that you look at the question. What are the coordinates of the rest stop? What are the coordinates of the rest stop? They've given you a description about the rest stop. The rest stop is halfway between the two cities. So thinking about your keyword halfway, halfway should signal you to think about midpoint. And so you must use the midpoint formula for this problem. For number 3, we're writing the equation of the line that is parallel to 8x plus 3y equals 12 and contains the points 3, 7. Analyzing the problem, you should point out 1, the word parallel, and second, we should point out the equation that they've given us. This is the original equation. And then third, we have our point 3, 7 for our new line. So 3 things. In this particular case, you should note that the very first step that we'll need to do in order to identify our parallel slope would be to solve our equation here for y. So first step, solve the equation for y. Once you've solved your equation for y, you should find out that your slope here is a negative 8 over 3. Thinking about the word parallel means that we have the same slope. So if we have the same slope, then we're going to need to use the slope, which is m equals negative 8 over 3, and our point, which is 3, 7, to find our new equation, or to find our b value. And then once you found your b value, we'll be able to write our equation. So step 3, use the b and the slope to write our equation in slope-intercept form. Which is y equals mx plus b. You'll need to replace the m and you'll need to replace the b. For number 4, we're asked to identify a quadrilateral that has the vertices A, B, C, D. Our side lengths are given to us as well as our slopes. We need to know, well, what is the best name for this quadrilateral A, B, C, D? So the very first thing that you should think about is taking out these 2 pieces of notes for this question. These 2 charts. Using this first one first, the very first thing that we're told to do is look at our lengths and then pick the correct category. So if we look at our lengths that we were given in number 4, we have that side AB here and side CD are exactly the same. And we also have the side BC and side DA are exactly the same. So in this case, we have 2 pairs of equal sides. 2 pairs of equal sides. So at this point, we're in this category. These are our options. We're either looking at a parallelogram, a rectangle, or a kite. Okay, after you have looked at your lengths, we're told to then look at our slopes. If we look at our other chart here, it'll give us a little bit more information about those slopes. So remember that the slopes can help us determine if we have a parallel versus a perpendicular line. Well, if anything is parallel, that means that they'll have the same slopes. If anything is perpendicular, that means that we'll have opposite reciprocal slopes. So first off, noting that AB and CD, those 2 opposite sides, they have the exact same slope. So that's a parallel set of lines or sides. BC and DA also have the exact same slope. So that's another pair of parallel lines. But if you compare these 2 slopes, your 2 sides that are right next to each other, the AB as well as your BC, notice how these 2 numbers are opposite reciprocals of each other. Since they're opposite reciprocals of each other, they are perpendicular. And so since they're perpendicular, that should give you enough information to figure out whether this is a parallelogram, a rectangle, or a kite. So for parallelograms, note that you had to have the two sets of equal sides. We did. Note that you have two sets of parallel sides. We did. But they don't mention anything about being perpendicular for a parallelogram. So this one we will not classify as a parallelogram. Your rectangle, we have our two sets of equal sides. We had two sets of parallel sides. And we also have perpendicular sides. This looks to be a rectangle. Your kite down here, there was a big thing that needed to be true if this was going to be a kite. And that was those two sets of equal sides needed to be next to each other instead of across from each other. In this case, they were not. So our answer for this one should be that this is a rectangle. For numbers 5 and 6, we needed to use the lengths from number 4. So for number 5, it says, what is the perimeter of quadrilateral ABCD? So here are our 4 lengths. In order to find the perimeter, you need to add all the sides. So add all the sides. For number 6, what is the area of quadrilateral ABCD? This is a rectangle, so remember that our formula for finding the area of a rectangle is length times width. So in this case, we need to multiply our two sides. 3 times the square root of 5 times our square root of 5. For number 7, we are asked to determine whether or not these points that are on two different lines are actually perpendicular. So whether or not the two lines are perpendicular. For this, we need to remember the term perpendicular and identify what we remember about perpendicular lines. Okay, perpendicular lines, if you can remember, they have opposite reciprocal slopes. So if you have a fraction that's a over b, it's going to change into a negative b over a. So negative b over a. For this, we will need to use the slope formula for a, b, and also for c, d. So you are using the slope formula twice, and then compare your slopes. If those slopes are opposite reciprocals, meaning that they have this pattern, then it is perpendicular. If not, then it's not perpendicular. For number 8, we have 3 different lines, and we're asked which 2 lines are parallel. So once again, noting your keyword parallel. Parallel means that we have the same slope. If you're looking at your 3 equations here, none of them are in slope-intercept form. So we can't immediately identify which of these has the exact same slope. So the very first thing you need to do is take each equation and solve it for y. For instance, if we take the first one, 2y equals negative 3x minus 4. Solving it for y would mean that we are dividing by 2 on both sides. And we'll get y equals negative 3 over 2x minus 2. In this case, our slope is a negative 3 over 2. So for the very first equation, the m equals negative 3 over 2. You'd need to do that for numbers 2 and 3. And again, you're looking for, well, which slope is exactly the same? Which 2 lines have the exact same slope? For number 9, you have the blueprints of the Jefferson Street Bridge are drawn on a coordinate grid. One support beam of the bridge lies on the line y equals 2x minus 5. A perpendicular brace passes through the point negative 8, 3. Write an equation of the line that contains the brace. So this is a word problem for writing our equations in slope-intercept form. So very first thing, noting that they want our equation, we're going to write a final equation in y equals mx plus b form. We'll need to fill in our slope, which is our m, and as well as our b, which is our y-intercept. So those are two things that we'll need to find. Well, we can identify our slope by looking at our important word from our word problem, perpendicular. You should note that perpendicular lines have opposite reciprocal slopes. If we look at our equation, it's already in slope-intercept form. So we can identify our slope for the original equation as a 2. So our new line will have a slope, instead of a 2 over 1, it'll become a negative 1 over 2. So a negative 1 over 2. Noting that that's our slope, and noting that you're going through the point negative 8, comma 3, we're able to then set up our equation as 3 equals negative 1/2 times our x, which is negative 8, plus our b, and then solve for our b. So this is 3 equals 4 plus b. Subtract 4 from both sides, and we'll have b equals negative 1. So our final equation would be y equals our negative 1/2, which was our m, so negative 1/2 x, plus our negative 1. Or we can write y equals negative 1/2 x minus 1 as our final equation. Alright, so we have number 10. Graph the 4 points and then find the length and slope of each side of quadrilateral ABCD. So when plotting each of the 4 points, it's very important that you plot them correctly, all 4 of them correctly. After plotting all 4 of them correctly, identify your sides. So in this case, we have a side that's labeled as AB. We have a BC side, a CD side, and a DA side. Your next steps are to find the lengths and the slopes. For the lengths, make sure that you use the distance formula. And you'll need to use the distance formula 4 times. So once for each side. That distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. For your slopes, you're going to use the slope formula 4 times. And remember that that slope formula is m equals y2 minus y1 over x2 minus x1. After you've figured out your slopes and your lengths for number 10, then you'll be able to identify or classify the quadrilateral for number 11, as well as explain your choice. This graphic here will be very helpful in identifying your final choice for number 10. So please use your lengths and your slopes and follow along with the graphic organizer that you were provided with in your notes. For number 12, we have a parallelogram. For this parallelogram, we are verifying that it is a rhombus by showing that it has perpendicular diagonals. So perpendicular diagonals. They want us to show that it has perpendicular diagonals. Well, remember that keyword perpendicular means that we're looking for opposite reciprocal slopes. And so if we're looking for opposite reciprocal slopes, then we're looking for a fraction that's AB, A over B, and the other one should be a negative B over A. So we're going to need to find the slope of DB. which is one of our diagonals. And we'll also need the slope for AC, which is our second diagonal. Once you've found these slopes, you're simply verifying that they are opposite reciprocals of each other. And if they are, you'll be done with your problem. So just find the slopes of those two diagonals. The last problem is number 13. One of Mrs. McNally's advanced algebra students really has to use the bathroom. Her classroom is located at Point McNally, as shown on the map below. So that's here. In order to make it to the bathroom, the student must choose the bathroom closest to Mrs. McNally's classroom. Which bathroom should the student choose? Provide the distance, rounded to the nearest tenth, to each bathroom to justify your answer. So, a key word within our little question here, which bathroom should she choose? Well, the student obviously wants to choose the one that's closest, so the one that has the shortest distance. Distance is a key word for us. Distance should signal you to use the distance formula. Okay, and so we'll use the distance formula, and we'll be using the distance formula 3 times. Once to go from Mrs. McNally's classroom to bathroom A. I'm just going to put bath A. Once to go from McNally's room to bathroom B. And once to go from McNally's room to bathroom C. There is one more key thing that you'll need to write for each of these points. You need to know what order pair is each of our rooms located. McNally's, bathroom A, B, as well as C. So for instance, Miss McNally's room is at the point 3, -2. Bathroom B is at the point -5, -5. Bathroom A is at the point -4, 5. And bathroom C is at the point 7, 4. Okay, using each of those points, use the distance formula those 3 times and figure out which bathroom is the closest to Miss McNally's room. The very last thing that's included within this study guide is your answer key. So for each question, please make sure to check your work. If you have any questions, please feel free to reach out to the teacher and ask questions.